Bismillahirrahmanirrahim. Chapter 1, Exercise 1H. It's all about indices. So first of all, let's discuss what do we mean when we use the word indices in math. So actually, when we have you can say repeated multiplication. For example, if I have 5 times 5 times 5, how can I write all this expression in the short form? So we can write it in a short form as 5 to the power 3. Now this 5, the number that has been repeated many times, this number is called the base. It becomes the base, and this number that is written in you can say in small writing, this little number is called the index or power. So we can say 5 raised to the power 3. 5 is the base and 3 is called the index or power. We have some rules to multiply the index numbers, or you can say the indices. For example, if I have 4 to the power 5 times 4 to the power 3, why the answer is becoming 4 to the power 8? Because 4 to the power 5 means that 4 will be repeated. If I expand it, it will become 4 times 4 times 4 times 4 and times 4. So I have to repeat it 5 times. Now the next one, 4 to the power 3. So you can say, you can write it as times 4 times 4 times 4. So total, how many times this 4 is repeated in this multiplication expression? So 4 is repeated 8 times. So no need to do all this step. Only think, like whenever you want to multiply the numbers that have the same basis, you can add their indices only. So look at this, here the index is 6 and here the index is 7, and the base for both of them is 7. So the final answer will become 7 to the power 13. So it can be done only when you have the same basis. When you have different bases, for example, if you have 4 to the power 5 times 2 to the power 7, so you cannot write its answer as a single base because both of them are having different bases. This rule could be used only when they have the same base. Similarly, what you can do for division, we simply subtract the exponents, like 5 minus 2, the final answer will be 9 to the power 3. And how actually it happens, you can say 9 times 9 times 9 times 9 and times 9, and you are dividing it by how many 9s? By 9 to the power 2, that means 9 times 9, and we can cancel these two, and then what is left? So 9 to the power 3 is left. So we can make a rule like simply subtract the exponents to get the answer when you are dividing two indices having the same base. Clear? Okay, so we have another rule. It's about, although I wrote over here all the rules, but we are going to discuss only 3 rules in this exercise. How can we multiply such numbers that are having the same base? How can we divide the numbers that are having the same base? And what if we have power to raised to another power? For example, 4 to the power 2 raised to 4 to the power 3. This shows now the base is this one. This is the base, and this base is repeated how many times? 3 times. So you can say 4 to the power 2 is repeated 3 times. So your final answer will become 4 to the power. Now add all the exponents, or you can say add all the powers, because all of them, they are having the same base. So keep the same base and simply add the powers. So it will become 4 to the power 6. From here we can make a rule that if you have a power raised to another power, simply multiply both the powers together to get the answer. So your final answer will become 4 to the power 6. As you can see here in this example, 10 to the power 3 raised up to the power 7. So simply you will multiply both the powers together to get 10 to the power 21. Clear? Now let's solve some questions from the book. Here are some questions. Okay, here they are saying find the value. So remember, there is a difference between when they say write it in as a single index, or when they say find the value. When they say find the value, that means they want the exact numerical value of this index number. So what do you have right now? 5 to the power 2. That means if you want to know what is the value of this expression, expand it. Like this is the index form, so expand it. It will be written 5 times 5. Expand it means like how many times you will repeat it for multiplication. So it will be repeated 2 times. 5, the base will be repeated 2 times. So 5 times 5 will become 25. So this is the value of that expression. Now here, if you want to get the value, it means expand this one and expand this one to get the value. So pause the video here and get the answer for number 6, and then we will solve number 11. So as you can see here, we expanded this 2 to the power 4, so it will be 2 times 2 times 2 times 2, and then 3 to the power 2 will be 3 times 3 times 3. So if you can do it directly, 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 3 is 48, 40 times 3 will be 144. Or you can make the pairs and then get the final answer. What about this one? Here actually this is 3.25, and if I write it in the, you can say, expanded form, it will become 10 times 10. That will give us 100. So it means this number of you can say this index or this power, it shows that how many zeros are going to be placed with 1. For example, if you will be having 10 to the power 5, that means 10 will be repeated 5 times, and finally your answer will become like that, like it will become 100,000. So here this number, it helps us to move the decimal. As you know that whenever we are multiplying with the powers of 10, simply you need to move the decimal to the right side, looking at the number of the exponent, or you can say the power, or you can say the number of zeros. It's the same thing. Here 2 says move the decimal 2 places to the right. Here these 2 zeros also say move the decimal to the right side 2 places. So finally your answer will become 325. Clear? So let's solve some more questions. Here they are saying write the following where possible as a single index number in index form. Why did they use this word as single number in index form? Because in the introduction I told you that when the bases are different, it's not possible to write it as a single base with the index. So only it's possible when they have the same basis. For example, here if you look at question number 16, the bases are exactly the same, so you can write it as a single number in the index form. Means the base will remain the same, 2, 2, and again in the answer the base will be 2, and simply you will add the exponents. Now get the answers of all these questions, then play the video to check your answers. Now as you can see here, only question number 18 is different from the other questions, because here the bases are not the same, so it's not possible to write it as a single number in the index form. So that's why I wrote over here not possible. This one, now some of the girls, they think like here how they will get the answer when you do not have any, you can say no, index is not written on any base. That means its exponent is, or its power is 1. So here nothing was written, so you can write 1 for yourself. So it will become 4 plus 1, the base will remain 2, and the power will become 5. Let's go to the next slide now and solve some more questions. So here again they are saying write the following where possible as a single index number in the index form. Now see, we have the division problems and we have power raised to another power. So if you from the introduction, as I told you, simply when we see that I will go to this question. Let's see this one. Okay, you can see that the bases are exactly the same, so I can write the answer as keeping the same base, and simply I will subtract the exponent. So 6 minus 2 will become 4. Okay, what if I have a power raised to another power? So simply we multiply the both the powers together and we keep the same base. So 3 times 2 will become 6. Keeping these two you can say examples or solve problems in front of you, solve the rest of the questions on your own, and then play the video to check your answers. So here are all the answers, girls. I hope you understand the exercise. That's all for this video.